Hi everyone. Hi everyone. Welcome back to the channel called Engineering Beyond Blueprints. As in the previous video, we talk about component engineering role and what is mean by component engineering and different roles and responsibilities. And in the previous video, we talk about passive component and different types of passive component. So it's a very wide subject that we want to talk about by segment wise. When I say segment wise, I just want to start with the resistor as a solution. We kind of understand what are the parameters we have to consider and which one is better, which one is not better, and all. So, but we didn't capture the reason for why we have to choose the better or non-better value when it comes for selecting the critical component or technical parameters of the resistor. So with that said, let's understand by segment wise as a resistor. As you know, resistor is basically used to control the flow of current, right, in the circuitry. So this is a major functionality of it, but I just want to talk about in technical as well as non-technical perspective. When it's a technical, we understood, okay, is control the flow of current, right? When it comes for non-technical perspective, when the user, I mean the followers want to understand non-technical in layman language, let's consider in the layman language. So I would like to correlate this one into the tap, the flow of water from the tap. So it's pretty much interesting, right? So I want to say how tap can be correlate with resistor. So as I mentioned, resistor going to control the flow of current from the circuitry, right? So similarly, as a resistor is correlate with the tap. So tap, it can kind of control the flow of water from the source of, to the different part of the circuitry. So when we release the tap, the flow of water will be depends on the release of the water, right? If you loosen up the complete tap, then water flow will be high, and if you keep in moderate, then the water flow will be less. So basically the resistor functionality is to control the flow of water or the current when it comes for a technical language. So there are different perspective or different categories or types of resistor. I would segment them into three different parts. One is by material, other one is by the composition material which is used to make these resistor, and third one is by application. So majorly when we talk about resistor, there are majorly four type of resistor which we could see. One is general purpose resistors, thin film, thick film, and foil resistors and metal film resistors. So so when by construction, if you see the carbon composition materials all are made with the solid carbons basically. So binder and high noise and low cost, basically this one. So wire wound resistors are resistive made with wire of ceramic core, right? So thin film is a lacquer deposition film. So it made up of these material when there is a low noise and high accuracy is required. So thick film resistors are made up of resistive material. It's a resistive paste material, I would say. It's basically used in assembly components, right? It's a surface mount devices. So when it comes for by material, right, carbon film resistors, as name implies, is made with the carbon layer by layer, right? So likewise, metal film also, as the name implies, is made up of nickel chromium film with a low tolerance and to maintain the high stability. So metal oxide is made up of oxide film to maintain high temperature stability across the circuit. So ceramite is basically a combination of ceramic and the metal. So which is used in precision trimming possibilities. When there is a need of trimming resistors, so there is a high chance of using this kind of ceramide composed materials to build the resistor. So fusible resistors are act like a resistors, which act like a, I would say, like fuse to protect the overload within the circuitry. It could be because of current or voltage, the sometime the entire circuitry may break down. So it's going to be protect with act like as a fuse. So by application, if you see, fixed resistors are standard one used every day in circuitry, when specifically in the lab equipments, right? We are using widely these kind of resistors, which are basically most of the application this kind of used, right? So variable resistors are kind of potentiometer, trimmers, and these are all used in control the resistance value, or increase the resistance value or decrease the resistance value based on need of application in the circuitry. So high power resistors are widely nothing but like wire wound resistors are widely used in industrial applications, where there is a requirement of high power supply and control the motor or the drivers, right? So precision resistors are foil or film, majorly used in measurement applications. So when I say measurement applications, so there could be a precision transducers, right? Transducers are widely used to measure the water level indicators, or it could be a speedometer and all. So where there is a requirement of measuring the value of the instrument, we are widely using these kind of precision resistors. So thermistors. So thermistor, there are two categories. One is on the NTC, I would say, and other one is PTC. When I say NTC is basically a temperature sensing devices. When there is a requirement of reading the temperature, we are using this NTC thermistors, and the PTC is used for protecting protection circuitry. So when we are kind of need of protection in some of the devices, right, this kind of PTC thermistors are being used. So let's understand. On the side, I want to little more talk about on technical parameters, right? So resistance value by default in nature, we should select the same resistance value when we go for recommending a new replacement solution. So tolerance is always less is better, because it's going to be very precise in nature to say it's not be going to be deviate in the resistance value, even though there is a high flow of current or voltage within the circuitry. So power rating is always better, is I mean higher is better. The reason why, you should have a handling the heating capabilities. So when I say heating capability, the unit of measurement, if you ask me, the power rating is in watts or milliwatts or watts or whatever you can say. So assume that there is a half watt part number, or the resistor gone obsolete, and when we are recommending, we should select the 1 watt resistor. The reason is going to be withstand when there is an high heating flow of current within the circuitry. So temperature coefficient always lower is better. This is we are measuring in the ppm. So if the existing component having a 50 ppm, and the recommended one having 100 ppm, then it is not the good in nature when it comes to stability. Like lesser the ppm is always better. So 50 ppm, when you are recommending a solution, if it is 25 ppm is great, right? ppm means we are measuring in parts per million, right? So package, as I said, should not be deviate, because the footprint, everything is should be match. If it is not matching, then it's of no use to recommend the solution instead of through hole to SMD and SMD to through hole, vice versa. So voltage rating, I would say always higher side is better, because it's going to be a reason behind why we want to say higher, because it's going to be more reliable, and the circuitry can withstand with higher voltage compared to the lesser voltage. So given that said, so we are not ending up here only. So we want to move forward with the next topic called capacitor, where I want to talk about more different type of capacitor, and what are the technical parameters, and which one is better, which one is lower is better or higher is better, and reason for why we have to select lower value or higher value. So with that said, I'm finger crossed and waiting for your feedback and see to come with more robust technical documentation or kind of tutorials in the upcoming video. Thank you so much for watching this video. Have a great day.